Sorry, no, it's just it's your talk. Scrolling, You know where you're set up.
I need to make that shielding.
I think we should have it right.
Yeah, very well.
Okay, I think we'll make a start now. We're slightly late. Thanks to all the fascinating discussion and talk we've had earlier on. We have this one last session, and we have done 4 papers in this session, all to do with, in some way or another, new technical developments, I think, and the new possibilities they might allow us. So without further ado, I think we'll start with the first paper, which will be Cornelius Meyer. And if I could ask all the speakers to keep the time, so that we have plenty of time for questions, and then we know over my watch. Cornelius, without further ado, at all order, efficiency, flexibility, comprehensive.
Thank you. It's good afternoon. Yeah, I'm Cornelius Meyer from Eastern Atlas, and my paper is. Can I go down here? Shit.
You need to press F5 first.
Yeah. Okay. No, it's not F5. It's a PDF. So.
Right.
Okay. I want to stay away from the technical aspects Paul mentioned. I will go more to some epistemic aspects of archaeological interpretation of geophysical data. But it would be nice to have this the next slide here. Can you help me? Because then you see. Okay.
So
yeah.
use the scroll button.
I will start with a small private confession, and I will tell you some things we already have got. I mean, all these beautiful multi-sensor devices in terms of multi-sensors, many sensors of one type or different sensors. We have software, a lot of data, and knowledge on archaeology and geophysics. Third point is the big data misconception, why Chris Anderson was wrong. It's about a comparison between data, big data in the field of social science and natural science. And we, in archaeological geophysics, we are somehow in between the both fields of science. And my conclusion is that I will tell you some things we need: humility, time, and hope. So let's go to this. So I was thinking of all these images we see, and I had a silly idea to make a little image search in Google to search for this string archaeological interpretation magnetic prospection. The result is you see a lot of data sets, but no interpretation, almost nothing that has to do with interpretation. I repeated this with another search engine, the same. There's aerial images with magnetic data, but there's no interpretation. So that's why I decided not to badger you with more images on magnetic data and possible interpretations. So let's go back to this slide, and I will start with point 2. In the last decade, everybody knows we have developed new technique. So we have got a lot of machines with multi-sensors that allows us to get a lot of data, big amounts of geophysical data. We have, thanks to the GPS technology, we can work with georeference data from the beginning. We can work with GIS systems that facilitates both visualization of geophysical data and interpretation. And the question is, what is interpretation? We had this issue before, just drawing anomalies, that's not interpretation, that's a correlation. And correlation is nothing, says nothing about causation, and it's not an interpretation. An interpretation has to be a translation to another language, and from numbers to some facts. Yeah. Okay, we have more things. We have possibilities for data storage. We have fast computers that facilitate all the work we do, and we have data. We have data that has some properties. The data is disturbed partly. The data is incomplete. The data shows different phases in one data set. So we have to distinguish between different phases from one data set, and that makes it difficult. And we have knowledge. We have databases. We have a lot of online sources of geophysical data in different sites, and we have libraries. Those things still exist. We can go to a library, get books out of it, and read about archaeological sites and geophysical data gained on them. And the amount of data gets bigger and bigger. I remember 2010 when our highly estimated colleague Wolfgang Neubauer inaugurated the Boltzmann Institute in Vienna. He claimed speed matters. So this positivist way of life or point of view did not make everybody happy, including me, because it's not only a question of collecting data and collecting data. The idea of the more data we get, the more knowledge we have about archaeology is wrong. And this is the point 3, the big data misconception. I will go to Chris Anderson, who was at this time the editor-in-chief of the Wired magazine in 2008, and he wrote an article that said the end of theory. The data deluge will end up with all scientific theory, with a scientific method, because he claimed that the numbers speak for themselves. But okay, this article was a provocation, and I think he did not even believe by himself of this, but it opened a discussion in the scientific community. What impact has this huge amount of data on the scientific method? Yeah, and I think everybody who is working with geophysical data, magnetic interpretation of magnetic data, knows that the numbers don't speak. We have to think about these anomalies, and we have to go into the interpretation with different concepts, and to prove these concepts by excavation, by other methods. Yeah, interpretation is not counting anomalies, it's more than just the sum of the anomalies. We have patterns, and the pattern itself doesn't tell anything about an archaeological site. We have to interpret the pattern. We have our today's concepts of settlements, and so that's why we recognize fairly easily Roman sites, because we are used to see this kind of structures, this kind of urban, this kind of idea of an urban space. But in the example of Neolithic sites, we have only slight ideas, maybe wrong ideas of the concept of space and room in a Neolithic society. So what we put in as an interpretation in a geophysical data set of a Neolithic site has more to do with our thinking of space and time today than with the idea of the society who created this these settlements. So then post-processualism was already mentioned before, I think. In 1999, Matthew Johnson stated, he wrote 8 key statements on post-processualism in archaeology. And I just choose the 5th statement, that is, the individual is active. That means a settlement pattern is not is not an expression of an abstract idea or abstract rules. A settlement pattern we can see partly in our magnetic or GPR data is a result of activity of individuals. So every settlement looks different, and we can think of models of it makes it easier of how did it look a Roman city, how did a Hellenistic city look like, but the single anomaly can't be explained using, or the single or patterns of anomalies can't be explained using these models. So we have to go to every site that we interpret with the idea that this is a result of a human activity of individuals, and so every site looks different. Yeah, let's go ahead. So that's why the automatic interpretation techniques are not really working well. They can help us for a kind of pre-selection of anomalies, but they have to be proven by the interpreters, geophysicists, archaeologists' eyes. I come to an end now, slowly. There's still time. From this statements with big data, with automatic interpretation, and the difference between ideal settlements and individual activities of human beings, we come to the point what we really need. And first point is we need humility, because there is no final interpretation. We never will get a final interpretation of a data set. We always have to consider our interpretation as a preliminary result and the process. And that's why the point of archiving is so important, because without archiving the data, the process will be stopped in one moment, and will never be continued when the data is lost. Sometimes it's hard to explain an investor that what we give is a preliminary interpretation, so better to write something like final interpretation of project X, because investors, as usually representatives of the neoliberal society, have a rather positivist view of the world. They only want to know yes or no. Is there archaeology? Is there no archaeology? If there is archaeology, can we exploit it somehow touristically? Is there no archaeology? So they say, okay, let's build some expensive crap there and sell it. And yeah, we need time, and it's even harder to explain to investors that we need time, because time is always money. But that's why I disagree with the statement that magnetic prospection is getting more and more cheap, or they're less expensive, because the time we save in the field by using these new machines to getting hundreds of hectares of magnetic data, we have to spend on desk later for starting with visualization, data processing, and interpretation. So this time has to be paid somehow. And yeah, the general conditions in our society are not the best to make it understandable that we need this time to get the knowledge out of this data. So that's why we need hope. Yes, the hope I will make a short excursus to another post thing. The interpretation of the past, even though its interpretation of numbers of geophysical data of an archaeological site is not only a technical act, it's a political act. Following the theory of post-structuralism of Michel Foucault, every interpretation of the past is political. And so we have to be aware that our decisions, our interpretation is a political act, since more political decisions will follow from our interpretation. And it's always good to, sometimes if there's enough time, to think about these points. So I'm done. Thank you.
Thank you very much, very well put. Are there any questions? Oh, yes.
Can I ask whether you're, in terms of archiving, to be slightly controversial, is your data just a snapshot in time as well? If you did the same survey in 50 years' time, assuming you'll have perhaps a kit, so you'll have different data as well. So, focus in previous talks, and you're saying that there's a need to archive the data right now, but surely we ought to appreciate that rather than returning to the data that you've collected, in 50 years' time, it will seem like some sort of antiquarian field notes that we get now, and the data that's been collected 50 years on will be completely different and better data.
I did not really get it. It was
the data.
Yeah.
Imagine an archaeologist in 50 years' time. Should they go back to your archive data from 50 years ago, or should they go back out to the site and collect new data? Because the geophysical instruments will be better.
Yeah, both. I would say both.
Assuming if I was still, what if the site isn't there? It's far away. In that case, or there's a massive, great skyscraper on it.
Yeah.
I mean, it may be that you can't get back to it, and that has already happened with some legacy data. It's quarried away now. So all we've got is the stuff that was done 20, 30 years ago. So
Yeah, in many sites, you won't get the same, or you won't get results anymore. If you think of, we do a lot of work in the Near East, and if you just think of the amount of waste that is accumulated on the sites there, then you can go with the best instruments there, and no chance.
Okay. I was just caught on what you said about the Neolithic and space, and actually I think that this is where sort of research and commercial part the ways, because I've done a lot of I've been involved in a lot of surveys going around the Stonehenge area for commercial purposes, and very much these are on narrow tracks of survey corridor where the object is very much, as was described earlier today, to find the archaeology.
Yeah.
Actually, what we know from the larger scale survey in the Stonehenge landscape project is actually it's the space that's archaeologically important as much as the individual anomalies. And I think there is this dichotomy. We can't always expect commercial archaeological surveys to act at the same level of finesse of interpretation.
And that's kind of the problem between the concept of ground value property and the concept of you still have it. There's a value of space that has an own value. So, but you can't sell it. So.
I think that comes under the umbrella of setting.
Are there any other very brief points anybody would like to make now? One more.
Very briefly, I was quite taken with your statement about magnetometer surveys not reducing in cost because the time saved in the field is being should be being used at desk. Yeah, should be being used.
Yeah. We at least we try to convince people that okay, we have these beautiful big machines, but we can't give you an hectare of magnetometry for 200 pounds or something. That's not possible, because for this amount of money you can't even do the visualization of the data. So yeah, you have to find a measure between the interests of authorities and investors and the general interest in archaeology. So.
Yeah, I think that's a very good point. Charge amount due to brain power, not. I think probably that's enough questions for now. We'll move on. Thank you very much, Cornelius.
Thank you.
Is it Rob Fry is going to give us the next talk? So Rob Fry, you're going to be archaeophysica, and you're going to be talking on multiple methods, geophysical necessity or optional luxury.
I'll work out how to
We might need your technical expertise. Is that working?
Now. Right, yes, so I'm Robert Fry. I currently work for Archaeophysica, and I'd like to talk about multiple methods in commercial archaeology. It's more a comment on the current status quo, as requested by the sort of CAGS brief we all got. Our main reason for discussing this method is because it's gone through too. Our main reason is because it seems to me like there's very much a one-size-fits-all approach to tendering for archaeological jobs. These are often set to the standard EH guidelines, and they basically cover 99% of the tenders we get in, for example. Usually we're not even told what sort of survey we want. We usually get an email saying, we need a survey. Here's a plan. It doesn't even mention the word magnetics or anything like that. It's just assumed these days that you're doing a magnetic survey. I'd like to state from the outset that I have nothing against magnetic surveys. In fact, we love magnetic surveys at Archaeophysica. They're pretty much 99% of our industry. But there's certain sites and certain times when they're not always the most appropriate technique to use. Again, for sort of 95% of the time, they are good surveys to use. However, when the site specifics show that they may not be the best results, or may not give you the best data sets, we think it's up to the archaeological contractor, or the geophysical contractor, should I say, to recommend alternative techniques, which we usually find are not met with the best enthusiasm, shall we say. The allowance. Now, the problem with this is due diligence for the companies. As a company, we want to give the best product. As Jim was saying, we don't want to fob anybody off. We want to give you an archaeological assessment, and we want to find the archaeology if it's there. This isn't always the best way of doing it if we're only using one technique. As we discovered from James's results, magnetometry was used quite a lot in the wrong conditions and the wrong sites. And I think as geophysicists, we're all used to hearing the phrase, "Oh, geophysics doesn't work." Well, generally most of the time it does work. It just depends on the technique you're using and if it's the right technique. When we get a quote in, we usually do a background check for sites. We look at the size of the site, we try and look at the soils and the geology that underlies the site. We look at if there's going to be any possible modern infringements, any pipelines going through. And then we look at our own database to see what our magnetic results have shown from the same sort of sites. From this, we can assess when magnetometry survey is going to be appropriate or not. And in some cases, we know it's not going to be appropriate. And we don't want to sell a bad product. So including a multi-method approach is becoming potentially easier and easier these days. Geophysical companies are adapting and growing, and we're able to sort of invent, if you like, new ways of collecting more data at once. This is our sledge array. You see we've got 4 cesium vapor magnetometers, and we've also got an EM31 going across. So we're able to collect the magnetic component of the data set, as well as our quadrature components, which can be assimilated to sort of the conductivity of the ground. This gives us 2 data sets at once, so we're not even spending any more time in the field collecting these surveys. As geophysicists, we're also blessed with many times of other array, and we all sort of know the various advantages and disadvantages of each array. We use, we've got resistance, magnetometry, radar, EM survey, to name just a few. There's also obviously electrical imaging and things like that. Each have their own merits in certain situations and should really be used more often. It was quite surprising that Arnie was saying earlier on that 41% of their surveys are radar. I know that may be more down to a practical aspect of kit being available, but potentially we should be thinking more about doing other methods rather than just magnetometry all the time. So I'm going to sort of teach you to suck eggs a little bit in the next few slides and show you some data from simultaneous surveys we've collected. That top image you see is the magnetic component of a quarry we surveyed last November. I wanted to extend this quarry into a field. Unfortunately, it looks like we've got some sort of dual phase, maybe possibly Roman faultlet on the site. So I'm not sure that's going to happen anymore. But you can see the in phase and the quadrature components from the EM survey conducted at the same time. And especially in the quadrature component, we can really see this nice band of very low conductivity, high resistance material we're getting from a completely different makeup of the actual hill that site was on. And it's giving you a lot more information about the magnetic accessibility of the ground. This is another site conducted in Cheshire. Luckily, this fort was already known about, I believe, before the survey. However, if a mag survey had just been conducted on the site, chances of finding it, or at least identifying it in a report, would be pretty minimal. As you can see, the electrical resistance survey has actually been extremely successful in locating the ditches of this fort and really sort of stapled that into the landscape. And this is data set collected with the sledge array you saw before, using the magnetics and the EM31 attached, so simultaneous collection of data. For this project in particular, the client wanted to know about the actual soils at sort of higher depths. We wanted to know about the gravels and the alluviums that might be present, which is why we sort of recommended using conductivity survey. But in this sort of snapshot of the interpretation, we've got the purples representing features that we saw in the conductivity, and the oranges represent features we saw in the magnetic data. And we're actually getting, again, a whole lot more information regarding the site we're surveying. It was quite surprising to hear from Ken earlier on that actually in 8 years, only one person or one company had come back to him and questioned the one approach technique. Because it's something we do relatively often at Archiphysica, because we don't want to sell you something that's not going to work. But the problem is convincing creators that they need it. This is an example of a conversation Martin had with someone only a few months ago. Basically, we were asked to do a medieval settlement, looking for potentially stone or wooden buildings. The site was right next to a busy road edge, probably pipes going underneath the site, and modern development either side of the site. So we suggested that potentially a resistance survey might be the best way to look for the settlement, as well as the MAG survey. But of course, constraints such as cost get in the way, and I'd rather have a mag survey that may not find anything rather than take an on advice of a specialist. So I think this talks basically a plea, basically, both to curators as well as us as geophysical contractors, that we should be providing the best solutions to problems, and curators should potentially be trying to take on our concerns more. As I think Jimmy was saying this morning, multi-method approaches should be used more often for the best possible results we can give. Thank you all for listening.
Well, very succinct talk there, Rob. Anybody have any questions or anything they'd like to raise on that? What question I'd like to ask, I mean, have you ever tried where there has been insistence? Or we just want magnetometry, have you tried offering a multi-sensor platform, trying to convince people that it's not that much more expensive to do the two techniques at once?
Yes, we do. We do tender, and we itemise the tender as well to sort of suggest, you know, you're only paying this much extra for the extra survey sort of thing. But usually the response we get back is that the contractor wants this one survey, and that's all we want. And it's for that last occasion we had to sort of sit down in the office and decide whether we even wanted to tender for it, because we sort of thought, well, what's the point in tendering for a job that potentially is going to be worthless? So it's a difficult. I know everyone's justifying costs everywhere, but it's a difficult situation.
That's an interesting point. Has anybody else in the contracting side ever decided to reject tendering for the job because they felt that they were being asked if it was worthless or not? No?
Doing it all the time.
I once didn't get a job because I said they were going to be wasting their time by doing one of the methods, because if they'd done this one, they would have got everything, and the other one was just because someone had decided they should do it, and I lost that. And they did it anyway, and they didn't get anything, surprise, surprise.
Well, that's the fear, isn't it? When you come back to a client and say, well, actually, we'd like to change what you suggest. There's a big fear, I think, within the industry as a whole, that then you'll probably lose the job, because everyone else is so competitive.
Which, to be fair, I did.
Yeah, and that's the problem.
We once won one where the client came back and said, we've chosen you, you're not the cheapest, but you're the only people who said it wouldn't work. So there you go.
Well, that's,
you just got to get lucky.
Yeah.
What about the using trial areas of the different techniques to demonstrate that what you're saying is reducing the client's risk, so that you have low cost.
The problem
1,
with
2, 3 techniques over a trial area, and then you then, particularly if you've got some crop marking or something like that, you can target.
The problem with that
on
is
from that, with a large area, because it is a big risk, to say, well, we're going to go for earth resistance as opposed to magnetometry. It's going to cost a lot more.
Yeah. Well, the problem can be with that though is that you end up going back to a site a few times, because you have to sort of go and do one survey, come back, report on it, and then they sort of come back to you and say, well, okay, that did work, we'd like to come back again.
Preliminary results.
What's it, sorry?
If you could do the preliminary results on the tests, which we've done on a number of occasions.
Again, it's a matter of cost though, because you're still taking time, you're still having to pay for that day out on survey.
Yeah, but it's considerably less than doing, say, 100 hectares.
Well, yeah.
The earth resistance.
Of course it is, but we all know that.
So do you find that you don't get much take up when you suggest doing a trial?
Well, you don't know who's offered what really. So, but it is a worry. It is a worry that you may not be successful if you challenge the decisions made.
Right. So you sometimes sort of feel apprehensive of challenging too hard what's been asked for. But I think there's a question.
Yeah, Matt Hart from Geometrics. I have to say the EM-MAG combination is great. I'm glad that you've sort of undertaken it. because it feeds into other disciplines like environmental archaeology and geoarchaeology, where their sampling strategies may not be landscape based as such with geophysics. So it can guide their sampling strategies quite heavily. So having that additional information, it might not provide anything towards the actual identification of the archaeological targets, but it will guide subsequent data acquisition.
Could I actually follow up on that? One of the examples you have there in 31 on stage, the M31 was not for archaeological purposes. But actually, Michelle and I were working on the same site. But because we knew they were basically, well, they're not belt pits, but they're natural style excavation. Anything over those hills is unlikely of archaeological interest. So A, the technical I'm working, B, are also zones that are not interesting, as well as having magnetic data for the high resolution.
Just as an aside, guess which company it was phoned me up and told me that my methodology was wrong. It strikes me that one of the problems, the problems here aren't geophysical, and the problems here aren't archaeological. The problem here is one of marketing. You have a product which has a given cost. You're competing against another product, which is, for example, trial trenching, which is a similar cost. You have to put the onus is on you to prove why your techniques are serious. And that's not something I can help you with, I'm afraid, but that is the challenge that effectively is being highlighted, I think, today.
Yeah.
One more question. Could you say your name, please?
Yeah, my name's Peter Turner. I'm a PhD student here. Just to follow up on that, how much of an issue do you think it is that, I mean, if I were a developer looking at tenders and I were a particularly unscrupulous and mercenary type, and I had one that was expensive but would find lots of archaeology, and one that was cheap and would find no archaeology on my site, I might be tempted to take it out as a win-win situation. Is that an issue?
Yes. Do I need to elaborate? Or
right, okay, I had to keep talking to the timer right down there. Right, well, thank you very much, Rob. And we're going to move on to our third talk now, which is from Mark Whittinger. And you're going to talk to us about should half-metre traverse spacing be the new standard for commercial magnetic surveys.
Yeah.
Let's make sure it's talk going. Is it up and running?
Yeah. So, should half-metre traverse spacings be the new standard for commercial magnetic surveys? Catchy title, I think you find. Notice as well that I'm saying that half-metre traverse spacings, I think, should be the standard. Shouldn't be used occasionally, shouldn't be used for research, should be the standard for commercial magnetic surveys, because the technology is there and we should be using it. The main thrust of my talk is whether better quality, higher resolution data is needed in commercial archaeological surveys. This talk could equally have been called nothing. Which one am I doing? There we go. What is the role of geophysics in commercial archaeology? Or if we're being a bit more philosophical about it, what are we here for? What's the purpose of the geophysicist in assessing the archaeology of a site? Well, for me, I'm involved in geophysical surveys because I'm interested in what's under the ground. And I want to get the best possible data that I can to help determine this. But as someone who runs a business, I have to do this cost effectively as possible. And at the same time, I need to make money. I'm not a charity or an academic institution who may only have to break even at the end of a year. You know, I need to make a profit. But all these things aren't conflicting. We can get high quality data, cost effective surveys, at an affordable price so that everyone's happy, I feel. So I'm here today to advocate the use of high resolution multi-sensor systems. In terms of multi-sensor systems, I'm talking about platforms that have got multiple magnetic sensors on, for purposes of this talk. Pretty much all the time, or most of the time, the position of data will be done by RTK GNSS. I don't think differential GPS should be used for commercial surveys anymore. Survey wheels can sometimes be used on these systems, but again, on most greenfield sites, they're not reliable. So we're talking about using GNSS, which is now widely available. Lots of people now use it, and it's integrated into most systems. So what are the advantages? The big one, the main one, is that we get an improved data quality compared to handheld systems. There's also potential for a significant increase in spatial resolution. So if we have a system that's got sensors spaced at half-metre intervals, we're possibly getting 3 to 4 times as many data points as handheld systems. That has to be a good thing in interpreting the anomalies and finding features. Almost a beneficial effect of it is that we get improved survey speeds if you've got multiple sensors on there. How quickly the survey speeds improve depends on the approach you take to how far apart you space your sensors, which I'm going to touch upon as well. There are disadvantages. We've certainly found with our system that we can't use it on all sites. Uneven sites, very muddy sites, ones with vegetation cover, we struggle to use it on. And as well as that, we've also found that it's not cost effective on smaller sites. Generally, we found when we use our multi-sensor system that we're very cost effective on medium and large sites. When you take into account setting up the system and taking it apart for small sites, you could almost survey it with something like a Bartik in the time it takes us to do that. So there are limitations to this type of system. I said that I think the data quality is better. And this is a slide to kind of demonstrate that. These are basically adjacent fields, it's not the same field, and you'll notice I say it's difficult site conditions. This was newly seeded and it was in the autumn, and we'd had obviously loads of rain. These were incredibly muddy fields. It was almost impossible to consistently walk across the fields 30-metre grids or 20-metre grids even at a regular constant pace. So this data here, this is actually after processing, so we've tried to destagger it, do as best we can to clean it up, but you can obviously see that there's still issues with the data. You can still obviously see archaeological features in it, but it's not the best data. In an ideal world, we'd have actually pulled off site and said, we're sorry, the site conditions aren't suitable, we can't get very good data. But in this case, there wasn't anything that you could do about it. It wasn't if it was a ploughed field, it could be harrowed so you can survey it better. The ground was just too waterlogged, and within the time constraints of this project, he said, well, any data is better than nothing. But at the same time, on the same site, we're using our multi-sensor system here. It was a slog to try and put our car system through this mud, but you can see it's worth it. It was worth it for the site fields we could use it on. Obviously, the data quality is much better. The background, we're seeing the anomalies. We're also getting resolution here. You can see there's actually looks like 2 overlapping circular features there. So not only are we getting good data, we're getting good high resolution data. But as I said, we can't use our cart system on every field. We'll probably survey about a quarter of the fields with the multi-sensor system, and then basically we had to stop simply because we couldn't put it through over the ground conditions. Another slide to demonstrate that multi-sensor systems do have great flexibility as well. This was a site where we actually surveyed in discrete blocks as specified by our client. And obviously there was quite nice archaeology coming up. Ridge and furrow, quite clear. And then the archaeology is very clear through that. Part, in fact, I think helped by the very uniform background that you get from having sensors on a platform. We actually decided, because the archaeology was so good, that we would survey a section here, walking in the other direction. So here we were walking this way, and here we walk that way. So we clearly demonstrated with this system that it doesn't matter which way you walk, you're still getting really good quality data. And this, again, this hasn't undergone any processing or filters or anything like that. It's simply been gridded and created to produce the data plot. Obviously, I mentioned that speed of survey, one of the factors on that is how far apart do you put your multi-sensor, do you put each sensor. We go for half metre all the time whenever we use this system because it's as cost effective as doing a handheld survey, if not slightly cheaper, we find, but you're getting that extra data quality. We could have gone down the route of spacing our sensors a metre apart, or getting a system that did that, and have dramatically improved survey coverage, you know, and getting a lot more work. But we didn't do that because we want to get the best data that we can. So this is a site where we actually collected at 0.5 metre intervals, but then for the purpose of this, I've effectively removed the data from every other sensor to effectively show what the data would have looked like with the 1 metre spacing. So is this good enough? Would the planning archaeologist be happy with this? Would the consultant be happy with this? Clearly found a very interesting circular feature. Clearly see on this data the suggestion of an inner circle as well. Some nice discrete responses in the middle. We've obviously got agricultural anomalies going up and down. We've got these discontinuous linears coming across there. Say a suggestion of something there. You know, we can clearly see there's nice archaeology. There's other things to go at. You know, generally, although the data is quite disturbed, that's due to the geology, not due to the data collection. So, is this sufficient for a trenching strategy to, you know, provide the overall assessment of this site, or could we do better? So this is the data at the 0.5 metre intervals. The face of it looks fairly similar. We've got, you know, a nice circular anomaly there. We've got obviously agriculture. We've actually got more agricultural anomalies here because I think on the 1 metre space and the extra interpolation you've got to do between your 1 metre lines is kind of obviously providing a smoothing effect. We still see our discontinuous anomalies and that sort of thing. But there are differences. Obviously, the 0.5 metre spacing, we had a clear gap in this feature and a suggestion of one there. We had our nice flow response in the middle. When we look at our 0.5 metre, there isn't a gap in this side, so you know it's not an entrance fair or anything like that. But interestingly, we've actually only got 2 larger strong responses in the middle there. And I think again this is due to the fact that with the 1 metre space we're effectively interpolating the data over that bigger distance, whereas with the 0.5 metre it's not so far. So we've got you see there 2 slight responses. And I think on the 1 metre space, and it's almost created those to be larger than they actually are. So effectively, we're almost creating artificial anomalies. Some of these negative that James talked about. With the 0.5 metre, I do believe we're going to get less of those. Obviously, this feature, it's now a bit crisper. The circular enclosure, or circular feature itself, I think has got better resolution. Oops, sorry. You can see that the internal response there as well is just that bit crisper. We've also got little things, again, it's possibly not archaeologically significant, but there's another anomaly coming down there. You can see it's only visible on the 0.5 metre compared to the 1 metre. But the really interesting thing about this data for the 0.5 metre are these in there. When you look at the 1 metre, we've got some isolated responses. You know, there's a cluster of them. Would that be picked up? Who there would have picked that up as something to target? Is it just a bunch of discrete responses amongst lots of discrete responses? When we look at the 0.5 metre, there's much more of a suggestion of a regular pattern. Responses around the outside of the one in the middle. Unfortunately, this site is going through a long planning application, so it's not been excavated. So I don't know whether they're caused by subsurface features or whether it is just a coincidental accumulation of modern features or geology. But that is something based on this data that you would strongly be recommended should get targeted with trenching. If we'd done a 1 metre traverse on this site, I don't necessarily know whether we'd have gone with that with the same confidence. So potential, the discrete features that we all struggle to find using geophysics and archaeology, possibly here we would have found it with 0.5 metres when it wouldn't have been found with a 1 metre. As I said, there are limitations to multi-sensor systems, or we've certainly found it with our particular system. They can't be used on some site conditions. As mentioned, you know, the ground conditions do affect it more significantly. Possibly not cost effective on small sites. But where they can be used, I certainly think it should be, and I think it should be as standard. Because we're getting that extra amount out of the data. It kind of goes down to which way we go. Are we looking for, when more and more multi-sensor systems get used, are we looking to get constantly greater coverage with an improvement in data quality possibly because of the greater stability of the sensors on a platform, but with little increase in spatial resolution, or are we looking for improved data quality with greater resolution? Certainly you get better data quality from them, and as I mentioned, with the half-metre space, you can get an improved interpretation, better identification of discrete features. There's obviously a precedent for changing the resolution that we record surveys at. When I first started, it was still 1 metre by half metre. Obviously, as technology improved, standard became 1 metre by a quarter metre. The technology is now improved again. Should be half metre by quarter metre, I think. Obviously, one of the limiting factors for increasing resolution is cost. As I mentioned, we certainly don't find that doing half metre intervals has an impact on cost. Obviously, you could argue if you're going to use multi-sensors, go down to a quarter metre, but I think that does have an impact on cost because you've got to have a very big array of sensors to do that. So I guess fundamentally, my talk boils down to what's the role of geophysics in commercial archaeology. And does data quality matter? Are we just looking for geophysics to find the general areas of archaeology that can then be targeted by trenching? Are we looking for the geophysics to find the blank areas where there may not be archaeology? Or are we actually going to be using the geophysics to get as much information as possible which can better inform any follow-up work? I'll bang on about it, I'll keep banging on about it. I think providing a better resolution has to be the way that we go. Well, that's what we do. Whenever we can, we prefer and recommend the increased resolution option. At the moment, because of the way things are, on a lot of sites, we'll actually go there with our multi-sensor system and the Bartikins. So if the site conditions are suitable for the multi-sensor, we can use the Bartikins. And also, we're obviously tendering against other companies who are just using 1 metre spacing, so we have to be competitive. Interestingly, about 3 months ago, we quoted for a job which was on a pasture field ideal for our cart, about 10 hectares. It turned out we lost it on a competitive tender, which is fair enough. We lost it by £95, and the company that won it were using 1 metre by half metre. We proposed to use half metre by something like every 15 centimetres, and that didn't factor into the overall decision on whether or not we won the job. So yeah, that's me done.
Well, thank you very much. Are there any questions? Should we be switching back using half metre all the time? John Gator?
Just one point, lots of interesting things there, but I'll just talk about one point, costing. I think as geophysicists we sold ourselves down the line many years ago when we started cutting the hectare rate to satisfy the consultants, developers. Sorry, I don't mean to put consultants on the side. To satisfy the developers, we cut our costs to ridiculously low levels, and everyone's suffered since. I don't think that the arrival of a cart system should mean we start doing things cheaper.
Absolutely.
Our philosophy is we do it more expensive with the cart because you kept collecting better quality data, and we have put out tenders whereby we say we charge more for cart data, and clients have gone with that. And I think that's the way it should go. We shouldn't be cutting the cost of cart just because you can theoretically collect data quicker in the field. There's all the questions which have been raised earlier about the processing and time afterwards. So for God's sake, don't let's sell ourselves down.
Absolutely. At the moment, we're costing our cart surveys at the same price as the Bartington survey.
Well, I think that's stupid.
I know, but we've got to absolutely. we've got to demonstrate to the clients. It seems like it's logical to use that wherever you can. We've got to demonstrate to our clients the benefit of it. And now we are getting 2 or 3 clients who will come to us and will say, can you use your cart on this particular site? And if so, they will specify that they want a high resolution survey. So at the moment, we're going in to demonstrate the benefits of this. I'm not doing it as a loss leader, because as I say, I've got to make money, but at the moment, I'm trying to demonstrate it so that we can come and we can argue to the clients, to the consultants, to the developers, you should be using this higher resolution all the time. And then once that becomes standard, obviously, we can increase the prices. That's the way we looked at it. Because if I just came in and said, again, the 10 hectare site's a perfect example, that was based purely on cost. So yeah, that's the view that I'm looking at it from.
I think I'd just like to stress my comments relate to cost. I'm not necessarily agreeing with you that it ought to become standard.
Right, yeah, absolutely, yeah.
Yeah, I think that's a good point there, actually, Chris, because of course, I mean, why not 45 centimetres? You know, why not 40 centimetres between separation? Because actually, the answer to that question really is one that you asked about. Is the 1 metre sufficient?
Mm-hmm.
Okay, and in some certain circumstances, it is.
Yeah.
And so so to drive this down, I mean, I was at a meeting a year or so ago when Wolfgang Neubauer stood up and said, well, of course, there's only one way to do survey, and it's my way, right? Okay, now, what he was illustrating there was actually that drive towards bigger, better, high-density surveys. And of course, there is some ideals there, but actually sometimes they're overkill. So I'm not suggesting that we don't require better resolution, but it's
But
why the 0.5 or why not 0.75?
Well, ease of setting out as much as anything else. But
is that a sufficiently strong reason so that you can say this must be the new standard because it's easier to set out?
No, but it's easy to set out and it's a high resolution survey. 0.75 wouldn't be that much different to doing it in terms of setting out, but obviously 0.4 would be. Obviously, we've got to work in commercial constraints, and it's got to be, that time for setting out and surveying has to be a factor. But going back to what you said about how it's not always suitable to use or not always needed to potentially use at high resolution. How do you know that?
Well, the question they ask, I mean, it depends what the questions we ask. And if the questions are driven by planning, then you're answering the planning question. I suppose that's how I would say it. But I think there's a long debate on that.
Yeah, absolutely.
There's one more question. Oh, I think there's two more. Three. Second back row first. I'm sorry. Could you say your name? I think you said it before.
Yes, presumably collecting more than twice as much data means that you've got more in the interpretation. I find that actually adds a lot more to discovering data sets.
Well, I'm still allowing my time where I allow for interpretation isn't based on how many days I'm on site, it's the area. So I'm not really changing my interpretation time based on the fact I'm collecting quicker. I actually find with the multi-sensor system that we use that often the interpretation is quicker because you don't have the variable background noise. You've got better quality data, therefore it's easier to identify your anomalies within that. And we're also potentially getting fewer spurious anomalies because the data quality is better. So I'm not cutting the time that we're allowing for the interpretations, but I actually think for an equivalent size site, it's actually quicker to interpret multi-sensor data.
One more question?
Can I ask you about the size of the reports that you're producing? Does collecting a great amount of data increase the file size or use the area?
The hard copy paper report. Well,
the electronic report, the PDF, when you send the report through, does the increased data increase the size of the file?
I don't know.
One of my bugbears that I feel I'm just going to burden myself. There's a lot of people in the room who've heard me say this.
Yeah.
But all reports now that we get that are prepared in the planning environment need to be emailed, and they need to be one file that we can email to planning archaeologists and to developers. And you'd be amazed at the number of people who can't accept files that are greater than 10 megs, basically. And I just ask everybody in this room to be aware of that, because it's all very well having fantastic data, but it's unusable in the planning environment if you can't upload it onto a local authority website. So anything that increases the size of files needs to be really.
I take that on board, and obviously we do need to be aware of how the information is disseminated. But obviously, I don't personally think that's an argument for not collecting high resolution data, because what we tend to do, what we have done anyway, if we do a 100-hectare site, whether it's collected parties or multi-sensor, the files are big. Particularly if in some cases we're not given an OS map tile and we're actually using a scanned image or a raster image, you get huge files. So in order to get that file size down, we have to do very low resolution PDFs, and you lose the detail in grayscale, and therefore you can have an interpretation and someone's going, well, I can't see that in this PDF. So obviously what we tend to do is we have to reduce the file size to email to clients, but then also we have to put on the higher resolution reports and PDFs on a CD or via a file share and that sort of thing. So I take on board what you're saying, but I still think that's not an argument to reduce the resolution of the actual survey in terms of data collected.
I think this is one we could come back to one time. Great, I'll take two features. I think I'll trade you all the second. Feature heard. Making it a quick one.
It is a very, very quick one. Just on the file sharing scheme. Things like using Dropbox to, maybe put a link in the email to a Dropbox that all the data is available there.
Yeah, that's what we do.
I think this might be more aimed at Ken, but if you were going to go ahead and recommend trenching, do you think at what point would that improve resolution? If you've got that circular feature, you would presumably say that needs to be trenched. So do you need that extra level of information to be able to say that this is it? That this doesn't. At what point do you say it doesn't need to be trenched, and what point would you say it does need to be trenched?
I think I'm going to answer a different question to what you're asking. In that the circular feature isn't really the issue here. What I interpret from Mark's talk is that the more important benefits of this is the features down in the southeast corner, what looks to me like potential pit group or something like that. Now that's something that could easily be missed. The circular feature, yes, you'll spot the circular feature. The odds are, looking at that, highly likely we already know about that from aerial photographs anyway. What's more important to me is the more subtle and more ephemeral features.
But I would have picked that circle on the 1 meter one when you put it up on the screen. I'd have said I would have targeted that as potential archaeology. Just looking at that.
I think a lot of people. I don't know whether I would when I look back at the data on the change.
Obviously, planning applications is the significance of these heritage assets that need to be determined, and in many cases you can't avoid by not doing trenching, determining that can be the preservation and what we actually look at. Because if those turn out to be Mesolithic or Neolithic discrete features, we're looking at a greater significance than maybe some Iron Age, and that question needs to be answered.
Right, one more observation.
Just to comment that the data you show are just a decimation of, you went from an half meter and showing 1 meter, but there was already, I think, a really good increase in quality that was brought by using a card system, some sensors that are stable, without staggering, without grid matching, and in there already there is a really good improvement of quality. And that compared to some onset Barting, turn shaking and staggered that are corrected there, I think it's a really good increase, and that's really welcome.
Well, that's a good point. There are two different increases in quality.
Yes, absolutely.
I think at that point we'll need to move on. We'll have a discussion later. So our last final talk of the day will be. Will it be from you, Finn?
It's from both of us. First time we've had two people on stage at the same time.
I will be expecting no technical problems.
Oh yeah, well I hope so.
Don't let me tell you that they get 30 minutes because
Is that no chance? Sound runs down once and then your time is up. Right, we have both our authors, Finn Carter and Graham Atwood, will be talking about are we doing enough? Oh, I'm not going to read the whole time. Let's get on with the talk. Your time starts now.
Good afternoon. I'm Finnegan. I'm a PhD student at the University of Bradford, funded by GSB Prospection. And my work is essentially on how we can improve magnetometer data.
I'm Graham Atwood. I've been working in archaeology for 10 years, initially as an excavator, and then moving into geophysics, and onto the Bradford Masters about 5 years ago, and then onto GSB. So no further ado. Just the introduction here. One of the problems of going last, of course, is a lot of the points have already been made, sometimes several times, but I think that's to emphasise and are possibly good points. So what we've got here is just what we're going to do. Problems with traditional, or perceived problems with traditional magnetic survey, the rise of GNSS based survey, some alternative methods, look at a few case studies, and then we'll sum up at the end. So, just start up. We've got with a normal handheld Bartington data as we collect, as we've seen with Ken's talk and various others. You get stagger, you get tilt, processing, plotting levels. We also have sampling strategy issues sometimes. They're forced upon us at times that we've got to do certain strategies, and maybe they're not the best idea. I think Duncan looked at a fair few of those as well. And as has been mentioned, magnetometry has become increasingly seen as a one-size-fits-all method. So we're just going to go on. First thing, speaking from Thomas's very last point there, that some of the problems you get with some data is you can see the Bartington, you've got two people here walking consecutive rows. One person maybe their walking isn't so great there. You can see over the pipe here that person's maybe got it spot on. Could be various different reasons for this. This could have been in a very muddy spot where that's not. But you can see with processing, most of these problems can be got rid of. We've got in this part here a very confusing set of anomalies, and over the other side sort of cleaned up a bit, but it's still quite confusing at the 1 by a quarter detailed magnetometry is set out by English Heritage. So maybe moving to greater detail might sort some of these out. If we look at sampling strategies, what we've taken here is a data set that we collected as a whole field, but we've applied later some sampling strategies that we have been requested and we have done in various areas. This one's what we've called the checkerboard. We were asked to do 30-meter grids, as you can see, in that fashion over a whole site. So what we do, you can see that there are bits of things going on in various places. Can't really see. You can see there's obviously stuff going on. It's maybe a little bit confusing. If we show the inverse of that, so we flipped it around, suddenly the key thing here, and I think we'll flick between these two a couple of times, is you're almost looking at a different data set. There's clearly something going on here and here. What's up here? That's gone. Over here, what's going on? This is a little bit different. And field boundaries and all field boundaries are sort of coming and going. So if I flip back between the two, you can start to see there. Really looking on. Same data set, have a look at doing stripes. So 30-meter consecutive stripes, missing 30, doing 30. Here, yeah, you can see there's possibly something going on, but you've obviously not got the turn, you've got two linears. Again, up here, it's quite confusing. Over here, yeah, you can see it. And you can see this boundary, obviously, all the way down. Move on to the next one. Again, you can just see that, yes, they are all picking up bits of archaeology, but the key thing is, that do you really know enough? Or would we end up going back and filling in that gap, and those gaps? And then it's time consuming. So if we have a look at the whole data set as one, you see that there's actually really quite a lot going on in there. With the same sort of data sets, if we look at plotting levels, you can see that this is -1 to 2 nanoteslas, with the that being positive. We can look on at 3 to 3, starting to lose a little bit of definition, especially around sort of these areas. If you pull it out to wider plotting levels, which is sometimes seen in various reports, 10 to 10, losing a lot. This is very strong archaeology, though, so you can still see all of these, but it's a very wide plotting level. And sometimes with more ephemeral archaeology, if you're using a very wide plotting level, you're going to lose some of that detail. So we're going to move on now to Finn, who's going to talk about GNSS survey, and he'll come back to me for some case studies later.
So we've heard a little bit about GNSS survey from the last couple of talks. I just wanted to highlight a few instruments. So the one at the top is GSB's custom system, which is 75 centimeter spacing, because it's quite a nice weight to pull around. Going down to ½ meter, to cover the same area, you'd have to have an extra 2 sensors. With this stopgap system we're using at the moment, you have to have extra data loggers. All that adds up to quite a lot of extra weight. which when you can't take a quad bike on most fields, that's a lot. It's hard enough pulling that around as it is, especially when it's windy. Never mind if you added on an extra few kilos. The two systems at the bottom are two commercially available systems. So you've got a first year system and a GMH's Jeep system. This one towed by quad bike. Moving on, this is the field adjacent to the one we showed for the checkerboarding. This is data which has been collected with our cart system. See, this is, I'm going to initially describe it as raw data. It's not. We've zero and traversed it, but that's it. All the data is collected in straight lines, the same as you would with a normal gridded survey, and it's all interpolated along those lines. So we're not crigging to 0.15 by 0.15. This is interpolated to 0.75 by 0.1, because that's how many data points we're collecting along the line and how we're collecting data points between each traverse. Then I'm going on to some of the extra stuff that we get out of this cart-based stuff. We haven't really heard that much about it so far, which does work, which is nice. So it took Jimmy and I about 2 hours to make on the way back yesterday.
Only because the software played up.
So this is an initial kind of depiction of the topographic data we get out of our cart system, overlaid with the magnetometer data at -1 to 2. I find this stuff quite difficult to look at, but it is an interesting aid to the interpretation. If we then go on again, this is stuff that we can produce automatically, taking from the raw height data we get out of our GPS system and producing 1 meter contours, which we've overlaid onto our insert diagrams. So you can see here this rectangular enclosure. It's actually on the south side of this ridge which is running down. The other just figures this rock fracturing, which is only evident on one side of the ridge, whether that's to do with kind of alluvial washdown or something to certain sides, or more modern agricultural practices. We don't know, but it's an extra point that we can add in to our interpretations that we wouldn't have been able to do with a normal magnetometer survey. But there are issues. We have a pretty much total reliance on GPS coverage, and alongside that, mobile phone coverage or base station coverage, because it's RTK GPS. You've got to have a reference station. Do you leave a £14,000 GPS sat in the corner of the field? I don't know. That's quite tricky. Do you use so like Trimble VRS systems, so a mobile phone-based RTK system? And then you've got the issues with mobile phone black spots. You've got to have a mobile phone strapped to your car. That's extra magnetic things. And we found we've been on sites where there is no mobile phone signal. We've recently invested in a mobile phone base where we sit a much cheaper mobile phone in one corner of the field and it has a radio attached to it, and that rebroadcasts the VRS system out to our GPS. But we're not aware of anyone else having that system. It took us quite a long time to find one. So it'd be interesting to see what other people do about that. Steep slopes. I think we all have issues with steep slopes when we're doing normal magnetometer surveying. I don't like walking up and down with a body, and my stepping is terrible when I walk up and down with a body. But at least with the cart system, we don't have any stepping errors. Every data point has accuracy to less than 10 centimeters. So even though we're going up and down a steep hill, that's all right. Tall crop, I think we can probably go over the same crop that we go over with a normal Barty, providing the farmer lets us. But then they're equally wary about us walking on some crop as well. But yeah, so moving on from that, it's not just magnetometers that we can strap a GPS to the top of. This is Geoscan MSB25 with Trimble R10 on top of it, which we took out on a site a month ago, something like that. I'm assured it's much lighter now than it was at the time.
4 kilograms.
What we were doing about half a hectare an hour, something like that, 1 meter by a quarter meter, and we'll see later on we've got some really nice data sets out of that, which haven't taken a long time to process. It's very, very rapid processing. It's when you do these talks, you realise you don't actually have any pictures if you're walking around with the CMD and a GPS. But we have done it. This is a picture I had to steal off the website. So you can go out with multi-quality EM systems collecting both conductivity and in phase data with a GPS attached to the top and processes data fairly rapidly. And while it's not got a GPS on the top, is real-time positioning using a robotic turtle station and some very shiny, very close space GPR systems. And I apologise, Emma, for the delightful photo of you.
Okay, so we're going to look on some case studies now. What we've got here is some normal Bartington data. This is actually plotted at 50 to 50 because of the level of noise that you can see, and you just, well, can't see anything, well, I can't anyway. If we move on to, sorry, we're using complementary methods here. We went on, did a resistivity survey, and you can clearly see there are several features that you just cannot see in the magnetics. These are actually park and landscaping features of 19th century stuff going on, which is actually also the cause of the noise here. So it's quite nice there that mag being a one size fits all, in this case, obviously didn't know that till we got there, but by using a second technique, you can actually gain definitely a lot more definition of what's going on and a better understanding. I'm just leaving here. We've got a second one here. We were asked to go and do a survey a couple of years ago. Jimmy's looking down. Down in a school who were celebrating an anniversary, and they, luckily enough, in their school grounds, they've got a Tudor palace. So they came down and asked us to survey it, and we did so with magnetometry. This is actually a -5 to 10, so again, wide spacing. If you look up here, you can see an area that isn't completely disturbed. If we move on, we also did radar at this site. And you can see with the radar, in that blank area, we can see clearly there's walls, there's ranges, there's floor levels. There's just all sorts going on there.
I should add that that's not the really shiny Marla system. That's just half-meter traverses using an old sensors and software system.
So we got here, you can just see that blank area. What we later found out while we were surveying was that this area, before it became this school, was actually completely levelled with material that was brought in from the Blitz from London, and just completely levelled off, and all the moat area and everything were all filled in. So obviously, just sort of giving examples that where magnetometry may not always be the right situation to go into. The final case study we've got here, just moving on, things to talk to us about, is actually where we collected the data with Rogers ResCart.
So this is the smarts on the original OS maps as being the site of a manor, up where the only really distinct numbers are. So this is some data that was collected by university students with grad 601s, I believe, or was it FMs? I don't know. I'm assuming it's grad 601s. So we went back and we collected some 25 centimetre mag data with our cart. I don't really know why we decided that that would be a good idea, but it was quite easy, surprisingly. And you see this area here. I don't know how well it's come out on the projector, but on my printouts, it's a bit like the half-metre stuff we were seeing before, with the distinct pits that were showing up in the half-metre weren't showing up in the metre. You'd definitely be more inclined to say that there's something there, which you can't see at all in the original mag. Then we overlay, this is 1 by 1/4 alpha data from the GPS located ResCart. It's just none of these correspond at all to any of the mag. All of these features are different. Even this feature here doesn't line up with the data in the mag. If we flip back and forth, they're in different positions. And then we've done some gridded conductivity data. This hasn't got the GPS on it. So this should look like the res. And there are some bits which look the same, and there are some bits which look really quite different. And I don't know why that is. It would be really nice if people did know. But I think there are reasons not just to use one technique. We can't go out and say, oh, we'll definitely just use conductivity instead of res, because we're not seeing all the stuff that we would see in the res. Run out of time. So I think we might just skip straight to any questions. But
Sounds exciting.
yeah. So any questions?
That's my lot. Thanks very much. I mean, there's something for everything there. Everyone there. I think you really summed up quite a lot of points that we heard earlier on. So yeah, we have time for some quick questions now. I expect everybody's going to get back from a cup of coffee. So we'll take 2 or 3 quick questions, and then we'll go and have the discussion where we can discuss the points in detail later. Are there any quick observations? Mark?
Just a quick one. Your sensors are at 0.75 meters because it's easier to pull. That's almost as bad as because it's easier to set out.
I'd say it's not quite as bad as that. I mean, we've had to pull it around. We have to pull it around all the time, whereas our gridding out takes half an hour of the day. But yeah, at the moment,
I'm just thinking, how can we come to a consensus on do we need to improve on the 1 meter, and is there a consensus on what will, benefit against extra resolution?
I think we definitely need to improve on the 1 meter on certain sites, and I think the only way we can do that is with cart-based stuff. Whether we need to go to half meter all the time, I don't know, or whether we compromise on certain sites based on how easy it is to walk around in the field. That's where it is. It's one of the key things that we have to do. If you've got a quad bike and you can pull around 25 centimetre cesium systems with all the batteries associated with that, then that's fine. But if you've got to walk up and down field, because that's what the farmer allows you to do.
Yeah, we 95% now with hand tool, so exactly the same. We use to operate as, so again, there's different ways of doing it.
Yeah.
Are there any other quick observations now, quick questions people would like to raise at this point? Right, well, it looks like it's time for tea, so if I could thank all our speakers in this section, it's brilliant, a lot of food for thought. And thank all of you. Great.